Hello and welcome to this tutorial about doing the t-test for correlation, or if you want a correlation and regression analysis in JASP. So the file I'm going to use is the BAC data JASP file. Let's look at the data as usual. So basically what you can see here is a relatively small data set that involves 16 participants in a study. Each of them was randomly assigned a number of beers to drink in a, of course, controlled environment. And then what was also measured for each of these participants is the blood alcohol content 30 minutes later. And so basically we have two quantitative variables. And what we can do in this case is a regression analysis. So the idea is that we want to do a correlation and linear regression. Let me delete both of those. So the way you kind of get to that point is to go to regression, go to correlation to do the correlation analysis. And so basically the two variables we want to choose here are number of beers and blood alcohol content. And you can kind of see that one thing we see here is the correlation coefficient between these two variables. So the R, or Pearson's correlation coefficient, is 0.894, which is pretty close to 1. So this is a strong positive correlation. And this is basically what we want to use here. It's Pearson's R. That's the only correlation coefficient that we're using in this class. I just want to switch to this display pairwise check mark, because it basically just tells us what we need to know here. So the actual strength of the association and whether that association or correlation is significant as indicated by the p-value. So in this case, the p-value is less than 0.01, which basically tells us that we have a significant correlation. So this is kind of what we can do as far as the correlation analysis is concerned. You can also look at the scatter plot, and it basically gives us this. It tells us everything we need. It gives us the number of beers on the x-axis, because that's the independent variable, and the blood alcohol content on the y-axis, because that's the dependent variable. And you can include some options here for that scatter plot, but that is really not necessary. So we can basically do that. And then, of course, one thing we might also be interested in is what is the equation of this regression line that we see in the scatter plot. And in order to do this, we go to regression again and choose linear regression. So here we have to be careful that we choose blood alcohol content as the dependent variable and number of beers as a covariate. So the output of this model is a little bit difficult to understand because it contains a lot of information that, at least in this class, we're not using. In this table here, you can see the correlation coefficient that we had before, the 0.894. This is the correlation coefficient we also had up here. And then if you square the correlation coefficient, you get R squared, or the coefficient of determination, which is 80%, and that tells us that the number of beers explains 80% of the variation in blood alcohol content. So you can kind of think of that as an interpretation of the R squared, but you can also think of this as giving us a percentage, in this example, 80% of how well the straight line model fits the data. So we have an ANOVA table for this analysis. We're not really interested in that. But then the other thing we can see here is, let's not even look at the right part of this table, but we can basically see the intercept and the slope of the regression line. So if you kind of want to know what's the equation of this regression line here, its intercept, so where it intersects the y-axis, is negative 0.013, and the slope is a positive number, 0.018. So both these numbers aren't very big because the blood alcohol content here is measured using relatively small numbers. So that is kind of what we want to do in sort of the correlation analysis. The assignment that you have to complete is to do something similar for the lung capacity data. And the instructions are in the course room. And one thing I kind of forgot here, I apologize, is that up here, you can also put get the 95% confidence interval for the correlation coefficient. So the actual correlation coefficient given the data is 0.894. But if you want a likely range for that correlation coefficient, it is given by these two numbers, which is the confidence interval for the correlation coefficient. So that is kind of what we need to do for this analysis. Again, the assignment is to do something similar using the lung cap data. As always, make sure you export your results as a PDF and then submit that PDF. Okay, thank you for your time.